Good evening here, all of you friends. We are here discuss. We will discuss the topic of Wheatstone Bridge, and let us start. It is the Wheatstone Bridge. Basically, the use of Wheatstone Bridge is to measure the unknown value of resistance. So, we will use basically four resistance, as we can see here in the next slide. It is very useful bridge that we can use to know unknown resistance, as well as we can use this same bridge for using uh, temperature measurement, weight measurement, by knowing the unknown resistance or the parameter that is missing. So here Western Bridge, we will go first for measuring resistances. As you can see here, it is the basically circuit diagram of a Western Bridge. There are four resistors. One is resistor is variable, right, and R4 is unknown resistance. Okay, then the rule says that if you provide a DC or a DC power supply, there are four resistance. R1 is equal to R2 and R3 is equal to R4. Then if R1 is equal to R2 and R3 is equal to R4, then V output is equal to VA minus VB is equal to 0. So it simply says that voltage across point A and voltage across point B, it, they will nullify each other, and the value of output voltage will be 0. So the deflection will be 0. Now here is the calculation, mathematical calculation. As we know that V output is equal to VA minus VB. VA is equal to VDC. VDC is equal to is the power supply, and they are providing. We are using voltage divider rule. So R2 divided by R1 plus R2. Voltage across R2 is equal to R1 plus R2. This is a voltage divider rule. Let us provide the value. This is R1, R2, 3, and R4. So we are measuring a resistance at R3. V out is equal to VDC R2 upon R1 plus R2 minus R4 upon R3 plus R4. So V output upon VDC is equal to R2 upon R1 plus R2 minus R4 upon R3 plus R4. So R3 plus R4 multiplied by V output upon VDC, we supply, minus R2 upon R1 plus R2 is equal to minus R4. So the solving for R3, we can easily get that R3 is equal to R4 multiplied by 1 upon R2 upon R1 plus R2 minus V0 upon VDC minus 1. Okay, so this was the basic rule. Now how we can get the unknown resistance using three known resistance by applying an application of a strain gauge. So the definition of a strain gauge is when we apply the force, the length of the strain gauge will increase. So the strain is equal to delta L upon L. The strain gauge works like this, as we know that R is equal to rho L by A. Rho is the resistivity in ohms per meter. Okay, the length will R is inversely proportional to the L. So as we can say that L increases and A decreases, so the R increases. Okay, so R is directly proportional to the L, and the gauge factor is defined by delta R upon R0 upon delta L upon L, right? So delta L upon L is equal to epsilon. Okay, so R3 is equal to R0 plus delta R is equal to R0 plus delta R upon R0. We can write it like this. So R3 is equal to R0 in the comma in the bracket 1 plus GF epsilon 0 epsilon. So the measuring strain is the final equation we are getting is R4 upon GF R0, right? First of all, we will find out the. Okay, so this was the PPT. Stop. Thank you for listening.